Hi guys, tonight we're going to take a look at powers of powers, and so you should have the Power of Powers video notes. So it should say Powers of Power video notes on the top. So we're going to use what we learned in the previous lessons to find a shortcut for simplifying expressions with powers. So by power to a power, let me make this a little bigger so we can see it. That means that we have an exponent on the inside of the parentheses and an exponent on the outside of parentheses. So we're going to complete each statement by showing equivalent expressions, and equivalent expressions are expressions that are exactly the same, and our final answer will be written raised to a single power. So we want to write this answer so we only have one power instead of two. So 3 to the 6th squared. So that means that whatever's inside the parentheses, in this case it's 3 to the 6th, squared means I'm going to write it 2 times. And if you remember from our multiplication notes, 3 to the 6th times 3 to the 6th this is the long way, this is not the shortcut. There's 1 3 to the 6th, so I have 6 3's. And there's the other one, so I need another 1, 2, 3, 4, 5, 6. So when we write this as one base raised to a single power, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 threes. So this is 3 to the 12th. So we're looking for a shortcut. So if we had used what we knew about multiplication from a few notes ago, we could also have written this as 3 to the 6th plus 6, because when we're multiplying powers, we can add them, and we still get 3 to the 12th. So our answer is 3 to the power of 12. Let's take a look at example number 2. Example number 2, we have 5 to the 4th to the power of 3. So that means we need 5 to the 4th 1, 2, 3 times. Now I'm not going to write it out the long way like I did over here because it's too long. So we know from our multiplication of exponents that we keep the base, and so in this case our base is 5, and we add the exponent. So it would be 5 to the 4 plus 4 plus 4, and we would get 5 to the 12th, and that's our final answer. We're not going to evaluate that. So we're looking for a shortcut on how to go from here to here while skipping this step in between. That's what we're looking for. So let's go ahead and do example number 3. Example number 3 is 2 to the 7th to the 4th power. So that means I need 2 to the 7th 4 times. So it's 2 to the 7th times 2 to the 7th times 2 to the 7th times 2 to the 7th. So we're going to keep our base, and that's 2, and we have 1, 2, 3, 4 7s. So that's 7 plus 7 plus 7 plus 7, and that gives us 2 to the 28th. So again, we're trying to figure out how can I go from here to here and skip all of this in the middle. Last one, we have 4 to the 5th raised to the 5th power. So again, we need 4 to the 5th 5 times, because this 5 tells us how many times we need to multiply that out. So it's 4 to the 5th times 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 4 to the 5th. And when we add those together, we keep the base. And we have to add 5 plus 5 plus 5 plus 5 plus 5, and we get 4 to the 25th power. So again, how do we get from here to here and skip the steps in the middle? So you probably have noticed by now that if I multiply 6 times 2, I get 12. 4 times 3, I also get 12. 7 times 4, I get 28. And 4 times 5, I get 25. So the shortcut to go from a power to one base and one exponent is just to multiply the two powers together. But what you have to remember, and let's look at this example down here, is that we have to have parentheses. So this means x to the a, b times. So all we have to do is multiply a times b. And this parenthesis, just like the distributive property, when we do equations, this parenthesis here tells us that we have to do a power to the power. So all we're doing is distributing that b inside the parentheses. So let's do the shortcut for x to the third to the sixth power. So we're going to keep our base, and we're just going to multiply 3 times 6, and this is going to give us 3 to the 18th power. So we just multiply 3 times 6. A to the 4th to the 7th power. All we're going to do is keep our base, which is a, multiply these two together, which is 4 times 7, and we get a to the 28th. So what happens if we have one like this last example here? Well, the t squared is outside the parentheses, so we're just going to rewrite the t squared. This is what's being raised to the power. So that would be t to the 7 times negative 2. This t squared is going to stay the same, and 7 times negative 2 is negative 14. Now we have to look at the rules for multiplication, because that's what this is. So we keep the base, and now the parentheses are gone, so we're just going to add the exponents, and we add 2 plus negative 14, and we get t to the negative 12. We can leave it t to the negative 12. We can also write it as 1 over t to the 12th. Okay, what happens, and this is the next set of examples here, if we have more than one number inside the parentheses? Well, if you remember, if it doesn't have an exponent, you give it a 1. So this 4 gets multiplied with all of the numbers in the parentheses. So if we wrote this one out the long way, it would be 2x squared, we'd need it 4 times 2x squared times 2x squared times 2x squared. We can rearrange our 2's, so we have those next to each other. And then we can rearrange our x squared. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. And we have to add 2 plus 2 plus 2 plus 2, and we get x to the 8th. And that's our final answer. So how can we do this with the shortcut? Well, let's take a look. So we're going to do the power to the power. So it's 2 to the 1 times 4, and then x to the 2 times 4. This is going to give us 2 to the 4th power and x to the 8th. 2 to the 4th power can be written as 16, and x to the 8th is just x to the 8th. So we end up with the same answer. Let's take a look at example number 2. We have the quantity 5m to the negative 3 raised to the power of 2. So we're going to take that 2 and we're going to distribute it to both of these, and that 5 doesn't have an exponent, so we have to give it a 1. So if we wrote this out the long way, it would be 5m to the negative 3 times 5m to the negative 3. If we rearrange our constants, we have 5 times 5 times m to the negative 3, m to the negative 3. This gives us 25. This gives us m to the negative 6. We could also write that as 25 1 over m to the 6, because remember this one has a negative exponent. If we used our power to the power rule, we could save ourselves some time. It would be 5 to the 1 times 2, because we're multiplying 2 times this exponent, and it would be m to the negative 3 times 2, because we're multiplying the 2 times the negative 3. That's going to be 5 squared, which gives us 25, which is what we have over here. This is going to give us m to the negative 6, because 2 times negative 3 is negative 6, and we can also write that as 1 over m to the 6th. Okay, flip your paper over because it does have a back. And I would like to give those a try. And then we'll check the answers in class tomorrow. But there is one. The one that I would like to go over is number 4. And number 5 is very similar. So let's take a look at number 4. We'll do this one together. The rest of them you need to do on your own, and we'll go over them in class in the morning. So we have 2 different powers to powers here. We have c squared raised to the power of 3, and we have the quantity 3c to the 5th raised to the power of 4. So this one, again, we're going to multiply the power to the power. That's going to give us c to the 2 times 3, which is c to the 6th. The 3 does not have an exponent, so we want to give it a 1. So we're going to multiply that 4 times 5 and that 4 times 1. So we get 3 to the 4 times 1, or 1 times 4, and c to the 4 times 5. This is going to give us 3 to the 4th power, and this is going to give us c to the 20th. So again, we want to put our like terms together. So this is going to give us 3 to the 4th, and 3 to the 4th is going to give us 81. And then c to the 6th times c to the 20th. Remember, when we're multiplying like bases, we keep the exponents, and we keep the base, sorry, and we add the exponents. So we get 81 c to the 26th. Number 5 is similar to that, and then 1, 2, 3, 6, and 7. I'd like you to try those on your own as well, and we will check them in class tomorrow. If you have any questions, please sure to jot them down on your notes sheet. Have a good night.